If you woke up this morning and you had a piece of toast for breakfast, did you think about where the electricity came from? Did you wonder how it arrived at your home? Or did you think about how, if misused, electricity can cause injury? Well, if you're like most people, these things probably didn't even cross your mind. We tend to flip a switch or plug in an appliance and take for granted that electricity will be there to provide for our basic needs. If misused, electricity can be very dangerous and even deadly. You can't see, smell, taste, or hear electricity, so that makes it even more important that you understand how it works. And to help you understand electricity, there are a few terms that you must know because electricity is rather complex. By definition, electricity is the flow or motion of electrons through a conductor. Electricity is measured by its voltage and current. Current is the flow of electricity through wires. It can be likened to the flow of water through pipes. Voltage is the force or pressure of the electricity. It can be likened to water pressure through pipes. A material that allows for the easy flow of electricity is a conductor. The most common conductors used in the utility system are copper and aluminum. An insulator is the opposite of a conductor and does not allow for the easy flow of electricity. Porcelain and rubber are examples of insulators. Even at relatively low levels, voltage and current, if mishandled, have the potential to cause injury. Even the amount of electricity running through your home, if not handled safely, can cause injury or even death if it interrupts your heart's natural rhythm. Electricity becomes dangerous for people when direct contact with electricity is made. By nature, electricity is always looking for all quick and easy paths to the earth. And when it gets to the earth, it is distributed in the soil. The human body is a very good conductor of electricity because it is made mostly of water, which is a conductor. If you were to touch a wire that had electricity running through it, the electricity would use your body as a quick path to the earth. As you can imagine, electricity running through your body can cause severe injury and even death. We use electricity multiple times every day, but where does it come from and how does it get to your wall outlet? Before electricity can arrive at your home or business, it makes several stops along the way. A basic electrical utility system is made up of power plants, transmission lines, distribution lines, substations, transformers, and meters. Each piece of equipment plays a role in delivering electricity to you. To help you stay safe around electricity, it's important to understand how electricity travels to your home, what equipment is used to deliver it, and the potential safety issues posed along the way. Before electricity can arrive at your home to toast your bread, it has to be made first. Electricity is made or generated at power plants. Basic sources used to make electricity can be coal, water, natural gas, oil, nuclear, and wind. When electricity leaves the power plant, it is in its most powerful form, or as high as 765,000 volts. To compare, when it gets to your wall outlet, it is just 120 or 240 volts. From the power plant, transmission lines carry electricity long distances from city to city or from state to state. And these lines are held up and linked together by transmission towers, which are the big structures you have probably seen along the highways. These towers are usually about 100 feet tall and can be made of either metal or wood. Now, transmission lines are actually bare aluminum or copper wires which are conductors for the electricity. Transmission wires are larger than the wires on poles in your neighborhood. Porcelain insulators hold the wires in place and keep the electricity running through the wires and not through the tower itself. And remember, a conductor allows for the easy flow of electricity, and an insulator protects or does not allow for the easy flow of electricity. In addition to the wires carrying the electricity, 1 or 2 ground wires protect the tower from lightning strikes. These bare wires are not safe to touch at any time. You should never touch, climb, or go near the towers or wires. Before electricity can travel from the transmission system and be delivered to your home, it has to make a stop at a substation like this. You've probably driven by a substation and not even realized what it is or what it does. A substation is enclosed by fencing for safety and houses the equipment that changes the electricity from one level to another. The electricity coming from the transmission line runs through a substation transformer, which transforms the electricity or steps it down to a lower level, reducing it from as much as 765,000 volts to less than 39,000 volts. This lower level of electricity is easier to handle and is now ready to be delivered to your home or business. But before we move on to the distribution system, let's now review some transmission system safety tips. Always assume wires have electricity running through them. If you see a fallen wire, call 911 and your local power company immediately. Do not approach the wire or let anyone else near it. Transmission wires are bare and not insulated, so do not touch any wires. Do not touch or attempt to climb transmission towers. Do not enter a substation for any reason. If a child's ball or other object ends up in the substation, do not attempt to retrieve it. Call the power company to remove the object safely. Do not touch, climb, or cut holes in substation fencing. The fencing is there for your protection. Do not approach or attempt to climb on any electrical equipment, because if there is an equipment failure, it could cause injury. Do not attempt to steal copper or any other material from a substation. Copper is a conductor, so it is used to help deliver electricity. Stealing copper can literally steal your life. After electricity has been made and transmitted to your city, it's time for it to be distributed to homes and businesses. The distribution system carries electricity at lower levels for shorter distances, such as from city to city or neighborhood to neighborhood. Like the transmission system, these smaller distribution wires are held up by distribution poles or buried underground. These poles are typically 50 feet high and are made mostly of wood. While the distribution poles and wires appear harmless, they must still be treated carefully and with safety in mind. Even the amount of electricity delivered to your home can cause serious injury if mishandled. Let's now explain what's on a typical distribution pole from the top to the bottom. At the top of the pole are the primary or main wires. These wires are coming from a nearby substation and can carry anywhere from 34,500 volts to 7,200 volts. The most common voltage is 12,000. Remember, the electricity started out as high as 765,000 volts coming from the power plant and was stepped down to lower voltages at substations. If the electricity is going to a home, there is typically just one main wire. If the electricity is going to a business, there would be 3 wires because a business usually needs and uses more electricity than a home. These primary or main wires are often held up on the pole by a crossarm. The wires are held in place by insulators, which help to keep the crossarm and pole from becoming energized by the wires. The next piece of equipment typically found on a distribution pole is a lightning arrestor. This is similar to a surge protector in your home. A lightning arrestor protects the pole's equipment from being harmed by lightning. At about the same level as the lightning arrestor is the cutout. A cutout is similar to a fuse in your home. It protects the pole and its equipment from too much electricity. If a squirrel or tree branch were to come in contact with a wire, the cutout will open, indicating a problem with that section of the line. If you ever see an open cutout, be sure to call your power company. Below the cutout is the piece of equipment that looks like a can. It is called a transformer. It takes the electricity from the wires at the top of the pole and steps it down to the lower level needed for a home or a business. Remember, wires can either be on a pole or buried underground. If the primary wires are underground, then the transformer is the green box often found in front, side, or backyards. So, if you have overhead lines, you will have a pole and transformer. If you have underground lines, you will have a green box on the ground. Now let's get back to the pole. Under the transformer is another copper wire called the neutral wire. This does not mean it is safe to touch. The neutral wire is a return line that goes back to the substation and helps to balance the amount of electricity out on the system. Without a neutral wire, our appliances could get too much or too little electricity, which can cause damage. In recent years, the rise in copper prices has made it a precious metal, and as a result, copper neutral wires like this have become a target for thieves. Copper theft is a huge risk to the thieves because they can be killed by coming in contact with a neutral wire. However, it's also a big risk to the public. Many times thieves will cut the wire and leave loose ends hanging where people and animals can come in contact with them. Below the neutral wire is the secondary wire. After the electricity passes through the pole-mounted or underground transformer, it is carried in the secondary wire at the lower level of 120 or 240 volts. Under the secondary wire are the phone and cable wires. They are generally the lowest wires on the pole. Phone and cable wires are not safe to touch because they could become energized. For example, if a power line were to fall and come in contact with a phone or cable wire, the phone and cable wires can become energized. At the bottom of the pole are copper grounds. These are protective pieces of equipment. A ground is something that will take electricity to the earth. Remember, electricity is always looking for all quick paths to the earth. So, if there were to be a problem with any of the equipment on the pole, the electricity would be attracted to the copper ground because it's a conductive material and pass through it to the earth. Again, copper thieves seem to target copper grounds because they are at ground level. However, at any point in time, a ground could be doing its job and have electricity running through it, making it very dangerous to a thief or anyone who would touch it. And lastly, on some poles, depending on their location, there could be another larger wire running off it at an angle. This is called a guy wire. It is used to support a pole. Again, if there's a malfunction with the equipment, this wire could become energized, and if people aren't paying attention, it also could become a tripping hazard. You should never pull or hang on a guy wire either. Let's quickly review the equipment on a distribution pole. Primary wires are on top and usually carry 12,000 volts of electricity from a substation. A crossarm holds the wires up on the pole. Insulators hold the wires in place and protect the rest of the pole and equipment from having electricity run through it. Lightning arresters protect the pole and equipment from lightning strikes. Cutouts act like a fuse and open when there is a problem with a line or a section of it. The transformer takes the electricity in the primary wire and takes it down to a lower level. The neutral wire is below the transformer and acts as a line back to the substation and balances out the amount of electricity or load on the system. The secondary wire holds the lower level electricity after it passes through the transformer. The phone and cable wires are typically the lowest wires on the pole. Grounds are made of copper and take electricity on the pole into the earth. And on some poles, a guy wire is used to help support the pole. Now that you've learned about the basic equipment used to distribute electricity to your home or business, let's talk about some safety hazards that can be posed by this equipment. Electricity never shuts off, so if a wire breaks or falls down, the electricity is always looking for a path to ground. And the human body is a very good path to ground. Avoid all fallen wires and presume that they have electricity running through them. Do not touch any wires under any circumstances. Call 911 and your local power company immediately to report fallen wires. Also, do not touch anything or anyone the line may be touching. Objects can become energized just by contacting a downed power line. Even telephone or cable lines can become energized, so don't touch any wires. Electric wires are not insulated like power cords for home appliances. What may appear to be some form of insulation is actually weatherproofing material and does not provide protection and make the line safe to touch. Always be aware of overhead lines. Keep ladders, TV antennas, pool and gardening tools, satellite dishes, and any equipment away from all wires. You and anything you're touching should maintain a minimum of 10 feet of clearance from the wires at all times. Contact with underground lines can be deadly as well. Always call 811 before any digging project. By calling 811, you will be routed to the underground locating service for your state, and local utilities will be notified for your locate request. In some states, homeowners own the underground lines and facilities, so a certified electric contractor should also be called to mark the underground lines in these situations. If your vehicle comes in contact with a utility pole or wire, do not get out of the car. Call 911 and alert others to stay away from your vehicle. You are protected when you are in the vehicle, but the outside of your vehicle could have electricity passing through it, so it is unsafe to touch. If you must exit the vehicle because of fire or other imminent danger, remove all loose items or clothing and jump clear of the vehicle. Avoid touching the car and the ground at the same time. Land with both feet together, keep your feet as close together as possible, and shuffle away from the car. Copper theft can kill you. Do not attempt to steal copper from electric lines or facilities. Tell your friends and loved ones stealing copper is illegal and can be deadly. Before electricity is ready for you to use at your home or business, it has been made at a power plant, transmitted long distances at a high level through the transmission system, run through a substation transformer where it's taken down to a lower level, and travel shorter distances through the distribution system to enter your home or business. So, exactly how does the electricity get from the pole or green box into your home? It travels to your home or business through a service drop. Now, a service drop is generally a collection of 3 wires wrapped together. 2 of the wires carry 120 volts of electricity each. The 3rd wire is the neutral wire and a return path for electricity. If the service drop connects from the pole, it will run overhead to your home and connect to a weatherhead which is attached to your home. From there, the wires run down to the meter. If the service drop connects from the ground level transformer or green box, it will run underground to your meter. Electricity actually passes into your house through the meter. A meter is a box usually found on the side of your home and measures the amount of electricity that you use. It is owned by the power company. From the meter, the wires and electricity actually enter your home or building through a service panel that contains either circuit breakers or fuses. Your home or business owns the service panel and the wires inside. The service panel wires take electricity to different areas of your home. The circuit breakers or fuses protect your house from overloaded or damaged wires. At this point, electricity has arrived at your home to toast your bread or run your appliances. The electricity in your home is certainly at a lower and safer level than it was outside, but that doesn't mean it can't be dangerous too. Here are some important home safety tips to follow. If you are doing any painting or replacing siding on your house, remember to keep at least a 10-foot distance between you or any equipment you are using and any overhead wires or the service drop coming into your home. Do not ever attempt to remove your meter or the box which holds it. There are live wires behind the meter. In the event of a fire or other emergency, call the power company to safely turn off the electricity. Always have a certified electrician work on your service panel or circuit breakers. Turn off all circuit breakers before doing any electrical work. Don't overload your home circuits. Use surge protectors to help protect from any fluctuations in electricity. Don't use power tools or appliances with frayed or broken cords. Many older homes don't have the 3-prong wall outlets. Never cut the 3rd prong or ground off of a plug to make it usable in a 2-prong outlet. The electricity needed to toast a piece of bread takes quite a journey to your wall outlet. It passes through many pieces of equipment and, if misused, can cause injury. Electricity is made at the power plant and leaves the plant through transmission wires. This high-level electricity travels long distances through the transmission wires until it arrives at a substation. At the substation, the electricity goes through a transformer and is stepped down to a lower, more usable level. The electricity leaves the substation through distribution wires. It travels shorter distances through the distribution wires and arrives at either a pole or green box near your home or business. If it arrives at a pole, the electricity is changed again to an even lower level and is delivered to your meter by the service drop wires. If it arrives at the green box or underground transformer, it travels through wires beneath the ground to your meter. Once the electricity passes through the meter, it enters your home or business through the service panel and is distributed to your wall outlets. Electricity deserves a healthy dose of respect by those who use it or work around it. These safety tips will help to keep you and your loved ones safe and healthy. Always presume wires have electricity running through them and that they are never safe to touch. If you see a fallen wire, call 911 and your local power company immediately. Do not approach the wire or let anyone else near it. Do not touch anything or anyone the line may be touching. Objects can become energized just by contacting a downed power line. Even telephone or cable lines can become energized, so don't touch any wires. Do not enter any electrical substation for any reason. Do not approach or climb on any electrical equipment. Always be aware of overhead lines. Keep ladders, TV antennas, pool and gardening tools, satellite dishes, and any equipment away from all wires. You should maintain a minimum of 10 feet of clearance from the wires at all times. Contact with underground lines can be deadly as well. Always call 811 before any digging project. If your vehicle comes in contact with a utility pole or wire, do not get out of the car. Call 911 and alert others to stay away from your vehicle. If you must exit the vehicle because of fire or other imminent danger, remove all loose items or clothing and jump clear of the vehicle. Avoid touching the car and the ground at the same time. Land with both feet together, keep your feet as close together as possible, and shuffle away from the car. Copper theft can kill you. Do not attempt to steal copper from electric lines or facilities. Tell your friends and loved ones stealing copper is illegal and can be deadly. Do not ever attempt to remove your meter or the box which holds it. There are live wires behind the meter. In the event of a fire or other emergency, call the power company to safely turn off the electricity. Always have a certified electrician work on your service panel or circuit breakers. Turn off all circuit breakers before doing any electrical work at your home or business. Don't overload your home circuits. Use surge protectors to help protect from any fluctuations in electricity. Don't use power tools or appliances with frayed or broken cords. Never cut the third prong or ground off of a plug to make it usable in a two-prong outlet. And finally, don't take chances with electricity and your safety. If you need assistance or more information, please contact your local power company.